an example for a simple linear regression model, let's consider this question. An experiment was conducted in a supermarket to observe the relationship between the amount of space allotted to a certain brand of coffee and its weekly sales. The amount of space allotted to the brand was varied over 3, 6, and 9 square foot displays in a random manner over 12 weeks, while the space allotted to competing brands was maintained at a constant space for each week. The data it writes shows the space allotted and its corresponding weekly sales. So we see the space allotted in this column and its weekly sales in this column. What we want to do, number one, is find the simple linear regression model appropriate for the data. Number two, determine the sample correlation coefficient. Number three, calculate R and R squared and interpret. 4, what percentage of the total variation of weekly sales is explained by the single predictor space. Number 5, find a 95% confidence interval for the mean weekly sales given that 6 square feet is allotted for display. Number 6, use a 95% prediction interval to predict the weekly sales at some time in the future if 6 square feet is allotted. And when you're looking at this, the first thing you probably want to do is create a scatter plot. So we'll go to Megastat, come down to correlation regression, and across to scatter plot. The horizontal axis, we like that to be the independent variable, and essentially we're free to put space at whatever we want, apparently 3, 6, and 9 square foot sections. The vertical axis, we like the dependent, and we're thinking that sales is dependent upon space. In other words, common sense will sort of tell us the more space you allocate, probably the more sales you will have, because consumers will easily find the coffee. Even those consumers who do not necessarily want that brand might be drawn toward it because it has a huge display. The alternate, if you have a really small display, it's really easy to overlook it, and consumers probably would not notice it unless they're specifically looking for that type of brand. So again, sales would be our dependent. Chart title, let's call this coffee sales, and select OK. And we end up with a scatter plot like this. Now Megastat does some other things beyond just a scatter plot. What you see here is the actual regression line, which we will be getting to in a second. Here's the equation for the regression line, and this is R squared, which we will get to in a second. The actual scatter plot is just these dots, and it looks like there is a linear positive relationship, as we kind of would think, that the smaller space allotted, the smaller your sales are. The larger the space allotted, the larger your sales are. Now we want to do the regression analysis on this. Question number 1 is find the simple linear regression model appropriate for the data. So we'll go to Megastat, come back down to correlation regression, and this time go to regression analysis. The independent is space. The dependent variable is sales. And for right now, let's leave no predictions and select OK. And we get a model that looks like this. So the first question is find the simple linear regression model appropriate for the data. And you see several things going on in this regression analysis, and let's just look at a few of these. You have R squared and R. Those are important. We have the p-value associated with the f-test is important. And then in the regression output, you have the p-values associated with your different variables. And the model would be that sales is equal to 307.9196 plus 34.5833 times the space allotted. And in the scatter plot,